So question 1 says determine the mass of lithium hydroxide produced when 0.38 grams of lithium nitride reacts with water according to the following unbalanced chemical equation. Well, before we do anything, let's go ahead and just balance this. I see 3 lithiums here on the left side, so I know I'm going to need 3 lithiums on the right side. So I'll tuck a 3 in there. That gives me 3 oxygens. So I need 3 oxygens over here as well. So I'll tuck a 3 in there, which gives me a total of 6 hydrogens here. Well, that's convenient because here are 3 hydrogens on the right with 3 more hydrogens here on the right as well for a total of 6, so this is balanced. So now let's go through and read it again, and let's make ourselves some notes here. Determine the mass of lithium hydroxide. So I'm looking for the number of grams of lithium hydroxide produced when 0.38 grams of lithium nitride reacts. Well, lithium nitride's right here, so this is 0.38 grams. So these notes will tell me I need to go from lithium nitride's grams to the grams of lithium hydroxide. So we can just set this up. 0.38 grams of Li3N. I don't want grams of Li3N. I need moles of it. Breaking out the calculator for this molar mass gives me that 1 mole of Li3N is 34.83 grams. Now I need to go to moles of the lithium hydroxide. So I'll put those moles of lithium nitride, Li3N, on the bottom. And I'll put moles of LiOH on top. And I see that it's 3 LiOH for every 1 Li3N. So 3 on top, 1 on bottom. And I'm going to run myself out of room here, but that's okay. I don't want moles of lithium hydroxide. I need grams of that LiOH. And again, one more time, we need the molar mass of this. So we'll just add together lithium, oxygen, and a hydrogen. And that gets me 23.949 grams. So then we just run this through the calculator, multiplying the tops and then dividing by the bottom. And then we should only have 2 significant figures here from the 2 provided in the problem. And this should come out to be 0.78 grams of LiOH. I would always stop and consider, what did I just do? Put a sentence to what I just did. I established that if I was going to react 0.38 grams of Li3N, I would end up producing 0.78 grams of LiOH. Number 2, what mass of sodium chloride is produced when chlorine gas reacts with 0.29 grams of sodium iodide? And again, the equation is unbalanced. So let's go ahead and balance that. I see 1 sodium on the left, 1 sodium on the right, 1 iodine on the left, but 2 iodines on the right. So I know I'm going to need a 2 out front here. Well, that messes up the sodiums. Now there's 2 on the left, so let's go ahead and put a 2 here on the right to fix that, which gave me 2 chlorines on the right, which I needed for the 2 chlorines on the left, so this is balanced. And let's read it again and make ourselves some notes. What mass of sodium chloride, so how many grams of sodium chloride is produced when chlorine gas, they don't tell me how much, so I'm just assuming I have as much as I need. It's irrelevant to the problem, with 0.29 grams of sodium iodide. 0.29 grams. So this question's asking me to convert from 0.29 grams of NaI to how many grams of sodium chloride that is. So we'll just start with our 0.29 grams of NaI. Grams of NaI on the bottom to cancel. I'm going to moles of NaI. 1 mole, get the calculator again, that's 22.99 for sodium, and iodine's 126.9. For a total molar mass of, let's see if I can squeeze it in there, 149.89. Now let's get rid of the moles of NaI that I just converted to, so that will go to the bottom. I'm working my way towards sodium chloride, so I've got to go through moles there. The ratio of NaCl to NaI is a 2 to 2 ratio, so you can put a 2 over 2, or if it makes you happy, you can just put a 1 over 1. It's the same either way. And now let's go to grams. Again, I don't want moles of NaCl. I'm looking for grams of NaCl, and 1 mole is 58.44 grams of NaCl. Plugging that into your calculator, and again, only having 2 sig figs here, should come out to an answer of 0.11 grams of NaCl. And if you're going to put a sentence to that one, you can make 0.11 grams of NaCl by reacting 0.29 grams of sodium iodide. Number 3, determine the mass of carbon dioxide. So I'm looking for the number of grams of carbon dioxide produced when 0.85 grams of butane, which they tell me is C4H10, so that's 0.85 grams of this guy, reacts with oxygen. They didn't tell me how much, so it's irrelevant to the problem, and this equation's already balanced, so we get to save a little bit of time. We're just going from grams of C4H10 to grams of CO2. 0.85 grams C4H10. I don't want grams of C4H10. I'm going to go to moles of it. 1 mole, we need the molar mass of this. That's 12.01 for each carbon times 4, plus 1.008 for each hydrogen times 10. Gives me a molar mass of 58.12. Now on to the mole ratios. I don't want moles of C4H10, so I'll go to the bottom. I'm looking for moles of CO2, and the coefficients here is an 8 to 2 ratio, so you can either put an 8 over 2, or like the previous problem, you can reduce that down to 4 over 1. And last, let's get rid of the moles of CO2. We're going to go to grams of CO2. 1 mole of CO2 has a molar mass of 40.01 grams. Again, multiply across the top, divide across the bottom. You should only have 2 sig figs in this answer. So it looks like it's going to come out to 2.6 grams of CO2. Number 4, determine the mass of antimony. Antimony is Sb, so I'm just looking for how many grams of Sb are produced when 0.46 grams of antimony 3 oxide. Well, that's this guy right here, 0.46 grams. Reacts with the carbon. They didn't tell me how much, so it's irrelevant as long as the equation is balanced, and it is. So we're just going from 0.46 grams of Sb2O3 to grams of Sb. 0.46 grams of Sb2O3 times grams of Sb2O3 on the bottom, go into moles on top. That guy's molar mass, antimony is 121.76 times 2 plus 16 times 3 for the 3 oxygens. That's got a pretty decent sized molar mass of 291.52. On to the mole ratios now. Mole of Sb2O3 on the bottom. Going to moles of just Sb on top. My coefficients here are 2 to 1. So 2 moles of Sb for every 1 mole of Sb2O3. And I've kind of come around a room, so let me just move this one down here. I'm going to multiply now by, still don't give myself much room, but that's okay. I don't want moles of Sb. I want grams of Sb. And that's just Sb's molar mass, which is what we said a moment ago, 121.76. Plug in this in the calculator, multiply across the top, divide across the bottom, only with 2 sig figs here. This should come out to 0.38 grams of Sb. Number 5, this time the reaction was not provided for me. So before we could even try this, we need to write the reaction out. But we're told that hydrogen peroxide decomposes Well, hydrogen peroxide, they tell me right here, is H2O2. So that's my reactant since it's decomposing. It decomposes into oxygen gas and water. You just got to do the water first. That's H2O. Plus the oxygen gas is oxygen. But since oxygen's diatomic, and when it's by itself, it must be O2. So now let's make sure this is balanced. Two hydrogens, two hydrogens, two oxygens, three oxygens. So we've got to fix that. Easiest way is to slap a 2 in front of the water. That gives me 4 hydrogens. So let's slap a 2 out front here to get 4 hydrogens. That gives me 4 oxygens on the left, but there's 2 here and 2 here to make 4, so we know we're balanced. Now we can actually read the question and see what we need to work with. What mass of this H2O2, so how many grams of H2O2, must decompose to produce 0.77 grams of water? So 0.77 grams of H2O. Putting that molar mass of water down here, it's 18.016 grams of H2O is 1 mole of water. The mole ratio here, mole H2O on the bottom, mole H2O2 on top. And I see a 2 and a 2, so I can put 1 to 1 if I'd like, 1 to 1, multiplied by, I don't want mole H2O2. I need grams of H2O2. Forgive me for running out of room again. 1 mole of this guy is 1.008 times 2 plus 16 times 2 is 34.016. 34.016. Multiply across the top, divide across the bottom. Again, you only have 2 sig figs from the information provided in the prompt. So this should come out to be, rounded to 2 sig figs, 1.5 grams of H2O2. Number 6, I see another equation was provided to me, but they're screaming at me that this one's unbalanced. So let's go ahead and just balance it. I see 1 carbon, 1 carbon, 1 oxygen plus 2 oxygens is 3 oxygens, but there's only 2 over here. Since there's 3 on one side and an even number on the other side, we know we're going to do something to balance this. I would just recommend throwing a 2 right here. That gives me 2 carbons, which I can put 2 here to fix that. Well, this 2 gives me 2 oxygens here, plus these 2 oxygens for a total of 4. And I needed 2 times 2, which is 4 over here. So this balances out. Now let's read the question. In the combustion of this, what mass of CO, so grams of CO, is required to produce 0.69 grams of CO2? 0.69 grams of CO2. Don't want grams of CO2, so it's going to the bottom. I want moles of CO2 on top. 1 mole is the molar mass of this guy, which turns out to be 44.01 grams. Times, get rid of the moles of the CO2. I need to go to moles of the CO. I see a 2 and a 2, so this is a 2 to 2 or a 1 to 1 ratio. And lastly, moles of CO to grams of CO. 1 mole of this guy is 28.01 grams. Plugging this in the calculator, 2 sig figs will be in our answer. Should come out to be 0.44 grams of CO. Number 7, again, it says it's unbalanced. Let's go ahead and just balance it before we do anything. This one looks a little trickier to balance, maybe. I see NO3 together. I see NO3 together, so I'm going to balance that as a unit. On the left, there's 2 NO3s. On the right, there's only 1, so I'll put a 2 here. That makes me have 2 sodiums, so I'll come over to the left side and fix that immediately. That gave me, means I need a 2 there for the 2 sodiums. That gives me 2 OHs, which is what I actually needed, so this appears to be balanced. Now let's read the question and figure out what to do. Determine the mass of sodium nitrate. So I'm finding the mass of sodium nitrate, which is this guy right here. How many grams of sodium nitrate are produced when 0.73 grams of nickel 2 nitrate? Well, this is nickel 2 nitrate, 0.73 grams. So we're just going from grams of this guy to grams of this guy again. 0.73 grams, NiNO3, 2. I don't want grams of NiNO3, 2. Forgive my parenthesis there. I want moles of it. NiNO3, 2. 1 mole. Just need to add up this guy's molar mass. Nickel is 58.69 plus 14.01 for the nitrogen, but there's 2 of those, plus 16 for the oxygen, but there's 6 of those, getting a molar mass of 182.71. Now, I don't want mole of the NiNO3, 2. I'm after mole of NaNO3, and I see a 2 to a 1 ratio here, 2 to 1, and now I'm out of room, so I'll come back down here again. 1 mole of NaNO3, and we need to find that guy's molar mass. Sodium's a 22.99 plus 14.01 for the nitrogen, plus 16 times 3 for the oxygen, comes out cleanly to 85.00. Multiply across the top, divide across the bottom to 2 sig figs. Looks like we get an answer of 0.68. 0.68 grams of NaNO3. And lastly, number 8, we're told this equation's balanced. That's a nice way to end this. Determine the mass of calcium hydroxide. That's this guy right here. So I'm looking for how many grams of calcium hydroxide are produced when calcium carbide, which is CaC2, and they don't tell me how much, so that's actually irrelevant to our thinking here, reacts with 0.64 grams of water. So I'll be going from grams of water to grams of calcium hydroxide for this last problem. 0.64 grams of H2O, 18.016 grams of water, since that's its molar mass, is 1 mole of water. Onto the mole ratios. I don't want mole of H2O. I want mole of CaOH2. Forgive that sloppy handwriting there. And I see a 1 and a 2. So this is a 1 to 2 ratio. And lastly, 1 mole of CaOH2. And we'll have to add up that molar mass. I don't know that one off the top of my head. It's 40.08 plus 16 times 2 plus 1.008 times 2. Gives me a molar mass of 74.096 grams. Multiply across the top, divide across the bottom to 2 sig figs. We end up getting 1.3 grams of CaOH